realized is that we can actually take the test before spring break. No, that's actually really good. I assure you. Really, like really good. So what we'll do is we'll just not do the lab until after spring break, because the lab has no impact on the test. What we're going to do is we're going to go day 2 today, day 3 on Thursday. We are going to review on Monday, and then we're going to take the test on Wednesday. And that actually works out infinitely better than any other plan, because what we were running into is that gives us 4 days to cumulative review, which means I can break the test down into like 15 questions a day. It'll be really good for us. Because remember, the finals were how much? Anybody paid attention? 20% of your grade. Yeah. What, Chris?
So I was gonna say, so what are we doing on Friday?
We don't have school on Friday. That's why that's why I'm trying to get this done. Because I assure you, we wait till afterwards, it'll be ugly.
So we test that Wednesday then?
Yeah. We're gonna test on Wednesday before. Yeah. Next Wednesday. Yeah.
When is the final?
I've got the final scheduled right now for you guys on the 20th of May. So graduation is not until the 26th. We're going to take the final on the 20th and the 21st.
Are you kidding?
What? Well, you said, are you kidding me?
We're just having a side conversation.
Oh, a side conversation. Okay. All right. So we're going to continue on with chapter 11. Did anyone go and do what I suggested? And look at those tables. No. Oh, there we go. Good job. Okay. So yeah, I would make sure I've gone and looked at them. We will, I believe, get to a little bit about them today. But it is 3:22. And this is going to be Chem 11:10. Chapter 11, day 2, and our objective is going to be able to determine bond angles. Though we did do this the other day, we're going to highlight it again today. Be able to determine bond angles, add H's. I'm gonna look the other side. Oh, add H's and draw condensed structures. Alrighty, so first thing I wanted to look at is this. Let's say I gave you this. I gave you this, okay? And I asked you to add H's to those 2 points. Would you be able to do that? Yeah? Okay, so how many H's would go here? Yeah, I'm going to need 1 H there, right? How many H's are going to go there? 2 H's. Now, let's say I do the exact same thing. Except now I do that. And I do the same thing. I want there, and I want there. Sorry. Let's say I do that. What does this signify? Double bond, right? So now how many H's do they need? This one still needs 1 H. This one now only needs 1 H, right? Because now that carbon has got 3 bonds. So just kind of make sure we understand that. Now, what if I did this? It's called a cyclical structure. Let's say I did that, and let's say I want to know how many H's go there and how many H's go there. So how about down here? How many H's does that need? 2 H's. Why does it need 2 H's? Because right now that carbon's got 2 bonds. It's bonded to that carbon and that carbon, right? What about this carbon, though? It needs 1 H. Why does it need 1 H? Because it's got 3 bonds. It's got 1, 2, 3 bonds. It needs 1 more H, okay? And that's how they'll draw. And these are all examples of what? What are all of these examples of? Skeletons, right? Skeleton structures. Alrighty, now, let's go check that, check that, check that. Just thought of something. What would the bond angle be right there? Is it? Well, so I'm talking about this carbon right here, right? How many things does that carbon have around it? It's got 3 things around it. It's got that one, and that one, right? Does it need an H? No, because it's also got 1, 2, 3, 4 bonds, right? Well, if it's got 3 things around it, no lone pairs, it has to be 120, right? What would its shape be? Trigonal planar. Trigonal planar. Just so I killed 2 birds with 1 stone right there, right? A little review there. Alrighty, now, let's say I did this. So start C and D. Alrighty, we're gonna draw these. Okay, we ready? Okay, I want to draw. So I'm gonna give you condensed. I want you to draw this. A little review from what we did the other day, right? So we're gonna go CH3. CCl3. I want you to draw the complete. This again is the what? What was this called? This is condensed, right? We're going to take condensed and turn it into a complete structure. Okay, and I want 5 hands. One. Two, 3, 4, 5. Alrighty. So Richards, what do you got for me?
I got a C with 3 CLs.
I got a C with 3 CLs on it.
Yep. And then
Okay.
To the left, a C.
Say that again.
To the left, you got 1 C with 3 H's around it.
Is he right? Okay. Now, what if I did this? What if I said shape and bond angle right there? Criddle.
Do you not have to do lone pairs on these ones?
Now, they will sometimes, they won't sometimes. I don't think so. Remember, these are going to be multiple choice, so I think it's relative. I mean, that's a good point. I mean, these would all need 3 sets, right? So, yeah, you could. I don't remember. I'll have to look. I don't remember specifically looking at that, but I will check that. Okay, what about shape and bond angle? Anybody got shape and bond angle here? Tetrahedral, why? Because there's 4 things around that carbon, right? It's got to be tetrahedral. What about bond angle then? Yeah, 109.5. And this is 109.5, not? No, not. About 109.5. Okay? Alrighty, what if I do this one now? Let's go here. We're going to go CH3. CH2 taken 4 times, CH, CH3 taken twice. Okay? Kind of an ugly one here, but we're going to go with it. Let's go 7 hands here. 7 hands. Iverson, didn't I say you two couldn't sit on the back row this time? No? Told my math classes that. They were really good at it too. I should have made you two sit up here in the front. One. Two. 3. Going for 7. Remember your numbers. 4. 5. 6. One more. 7. Alrighty, fish. What do you got?
Okay, so so the first one is a C with 3 H's around it.
Okay.
It's connected to another C with 2 H's, and then another C with 2 H's, and then another C with 2 H's, and then another C with 2 H's.
Okay, now what does that do right there? No, we need one more, don't we?
Yes.
Because that now gives me, these 4 are those 4, right?
Yeah.
That one is that one, correct? Okay, then what do I got?
A CH.
So like,
And then I just put the H projecting like the bottom.
so you went C and an H, right?
And then at the top of that one, I did a C with 3 H's because I didn't know where else to put it. And
Like
then,
that.
Yeah, and then out from the C back on like the main part, I did a C with 3 H's.
Does that work? Yeah, so these 2 are those 2. That one is that one. That one is that one, right? Now, could I have drawn this differently and still been correct?
Yeah.
Yeah, could the H have been up there? Could the H have been out there? Yeah, these can be anywhere, it doesn't matter. As long as they're connected properly. Okay? Is she right? Yeah, just like that. Good job. Okay? Is this starting to make sense or no? Yeah? Okay? Now, let's say I did this one. Alrighty, so now I'm gonna give you this one, and we're gonna go a little different direction here. Now, here's a skeleton. I want you to make that complete. I want you to take that, and basically you're going to add what? Well, yeah, you're going to put a C everywhere there's a what? Yeah, a change, right? And then I've also got to do what? Add a bunch of H's, right? So I want you to take that from a skeleton to a complete. Let's go for 8 hands. So 1, 2, 3, 4. Let's go 8. Did I say 8?
Yep.
Yeah. We're halfway there. 5. 6. 2 more. Not going to get there? Not going to get 2 more? No? Well, we're going to move on. So, Garrett, you raised your hand, right?
Yeah.
So, what did you do?
Alright, here's another shot. So I drew a sea of rings for that one.
So, I got a C, a C, a C, a C, a C. That's an O, right? Like that?
Yeah.
Okay?
And then I drew an H off of all those except for the O.
So, you get an H, an H, an H,
Yeah.
an H.
And that would be the. Okay. That would be a C actually.
That'd be a C right here.
Yeah.
Okay.
Then you have a C there and then an O off that and then an H off that.
Like that.
Yeah.
Okay.
And then I did lone pairs on that O up at on the top.
You put
And,
some lone pairs there.
And that other O.
Then you put some lone pairs there as well. Okay.
And then the C, like the C, C, O on like the little thing, the tail coming
Here?
off. Yeah, the tail coming off.
Yeah.
You need to have 2 H's for that with that C.
So you got an H, 2 H's there.
Yeah.
Okay.
You need to have another one on that other C in the ring.
One right there, right?
Yep. And then you have to have, don't you have to have a double bond with 2 of those?
Well, is there double bonds drawn here? No double bonds drawn there. You can't just make double bonds up.
Okay.
He's really, really close. What's he missing? Yeah, I just need an extra H everywhere.
Okay.
Now, are we good? Now we're good. You see what I'm saying?
Yeah.
Now, what is the shape and bond angle there? Around that O. Anybody know? It's bent, and it's about 109.5, which is pretty much every time I see what? Well, but every time I see O, it's going to be bent in about 109.5. Now, let's say because I can, I asked you this. And I'm only looking right here. And I asked you for bond polarity. Little review here. Anybody remember bond polarity? Little partial, those little funky, right? We have a what? If I got a polar bond, I've always got a slightly positive end and a slightly negative end. Does anybody remember how we told that? How we determined that?
Lone pairs.
Lone pairs was one. Another thing. Okay, we had numbers, but they're not going to give you numbers. So does anybody remember how we looked at that trend-wise? There was a trend we could tell on the periodic table.
O. Like the
Further
top right
up and
corner.
right.
Yeah, upper right is the most, lower left is the least, right? So if I'm looking right here between carbon and oxygen, oxygen is further to the what?
Right.
To the right, which means it's going to do what?
Be more
It's going to be more, it wants to pull those electrons closer, which is going to make it slightly what? Negative, which is going to make my carbon slightly positive. Okay? And that's based on trends. They will not give you the numbers. Okay? And they'll do it right in the middle. They'll draw something and go, what's the bond polarity right there? There's like 2 of them, I think. Yes?
So why isn't it from the O to the H? Why is it?
Okay, because here it would still be, but they'll specify which bond they're talking about.
So they'll say from the O to the C.
Yeah, they'll say something to tell you which two elements you're going to look at. Whichever one's closest to the upper right is going to be the negative one. Which one's further away is going to be the positive one.
It's that easy.
It is that easy.
I don't know why I didn't realize that on the other tests that we had this on.
'Cause I was going to, now see, but see,
Yeah.
you did notice that we've done what?
The test on
But we've done this before. So yeah. See? We're learning. Good job, Criddle. All right. Now, from there. Okay. So I need, man. Well, I'm gonna look at these really quick with you. Again, you need to go and look at these. Okay, these are those three tables. We're just gonna talk about them briefly because you've got to go and look at these. Now, the first table's easy. Okay, an alkane, I have all single bonds. An alkene, I have at least one double bond. An alkyne, I have at least one triple bond. Now, this is where you were trying to go. It's called an aromatic. Okay? An aromatic's what's referred to as a benzene ring. Okay, it's a cyclical structure with alternating double bonds. And it doesn't matter as long as they alternate. Okay? And it's going to look something like this. Notice, each one of these bonds are going to have the exact same shape and angle measure. If I looked at this one, every one of these bonds would be what shape? If I'm talking about around this carbon, they're all going to be trigonal planar, right? And their bond angle would all be 120 degrees, right? Now, to be a benzene ring, they have to have these. You can't just add in double bonds. Do you know what I'm saying? I'm talking to you because this is like that one we did, right? Now, they're the easy ones. Okay, these next, like 9 or 10 or however many there are not as easy. Now look, what you have, okay, is you have what is known as an alkyl halide. All they've done is they have replaced one of your carbons with a what? A halogen. Which is what? What are the halogens? Anybody remember? Group 7, right? So they put a Cl. We did one of these, right? We had a chlorine in there because you pointed out all the lone pairs, remember? That was you, right? Yeah. That's called an alkyl halide. Then you have an alcohol. Alcohols are any times they add an OH onto the end. We've also done that today. If I go back right here and I look at this one, this would be an alcohol because it's got that OH. Now, something you need to know about an alcohol. Anytime I see this OH on the end, and this is when it's on the end typically, what do I know about that? Does anybody know anything about an alcohol, no matter what it is? If it's an alcohol, it will do one thing. Well, okay, sorry, it'll do two things. Okay, I wasn't thinking that way, but you're right, it does kill things, so it's back, it's an antibacterial in that sense. What do alcohols do? Anybody know?
They dissolve in water.
They do, okay, and that's because they hydrogen bond. You're right. They also burn.
That's
They're
what I was gonna say.
yeah, they're combustible. What, Krill?
I was gonna say make you drunk, but I just realized that probably wasn't the answer.
It wasn't, but that is also a true statement. Yes. I was looking for one and I got 4. They dissolve in water, they do make you intoxicated, and they are disinfectant. I was looking for they are combustible. Go figure. I'll fix that for my next class, okay? So, what? Yeah. So I'll say, well, yeah, I'll just word that differently next time. Okay. They do at least, there you go. Yeah, I'll just reword that, okay? So, then I've got an ether. Okay, now notice, an ether is when I've got an O somewhere in the middle of 2 carbons. That O is in the middle. I've got an amine. An amine should never be missed because an amine adds an NH2 onto it. It's usually on the end as well. You can have any kind of chain, NH2 on the end, that's going to be called an amine. That comes from a what? Let me know where that comes from. Amino acid. Oh, yeah, see how that helps come into play right there. And then you've got a thiol. I'm going to be honest. You don't see thiols very often in nature. These are like in the chem lab type stuff, right? And that's when I'm simply, like an amine's got an N in it, a thiol has an S in it, a sulfur. Okay?
Wait, so that says like SH, is that a?
Well, yeah, I mean, it'll be an S and then it'll have an H on the end of the S. But it's because, but you can do that, like they can have an O and an H, but it's usually got something else. Like the amine has an N and two H's, it just depends. Yeah.
Can you ever have a combination of any of these?
You can. For what we're doing right now in the beginner section, there will not be.
Okay.
Let me rephrase that. I'm pretty sure there isn't. I will check because that would just muddy the water way too much. Okay? And then the last one is this group. And it's pretty much 3 and 4 could have been all in one table. But I've got an aldehyde. Oh, I know what. Now I see why they did that. Because now we got double bonds in these. All the rest were single bonds. So I've got an aldehyde. Now notice, this right here, this is where the hydrocarbon would be. So on the end of it, I simply have a carbon that is double bonded to an O. And it's got to be at the end of it. Okay, and that makes it an aldehyde. If I put that C double bonded to an O somewhere in the middle, now it becomes a ketone. Okay? If I put a C double bonded to an O with an alcohol, because that's basically what I've got here, a carboxylic acid, and this kind of goes back to what you were asking, is a combination of an aldehyde, the C double bonded to the O, with an alcohol. Okay? Then I've got an ester, which is where I've got my carboxylic acid, but now I'm somewhere in the middle of my chain. And then I have an amide, which is a aldehyde combined with an amine, makes it an amide. Okay?
So when it says R, like it says H4R or H4R, what is
That R is just any kind of chain. Yeah, it's a variable saying I've got some kind of hydrocarbon chain. There could be 1 or 2 or 3 or 4, however many carbon longs I want. This is what's happening at the end. Does that make sense? So the R simply means I got a chain here. At the end of my chain, I've got a C double bond to an O. No matter what it is, that's going to be some kind of aldehyde. If I've got a chain, but now in the middle I've got a C double bond to an O, now it's a
so it
ketone.
would be like a chain and then a C, the one to an O and then a chain.
Exactly. So here's a good example of that. So let's say I was going to compare those two, Richards. So if I was going to compare an aldehyde and a ketone, okay? So an aldehyde would look something like this. Something like that, let's say. And they will usually, they'll draw in whatever they've got. So if I had this, and then they would have, like, they would probably put that H on there to show. This right here, that's the R portion. This is what makes it an aldehyde. Okay? Now if I go ketone, ketone's now going to look like this, except now I'm going to have that. This is on the end, this one's in the middle. Does that make sense?
And the H is still.
Yeah, and I'd still have. But because here, that doesn't have an H on it because I've already got 1, 2, 3, 4 bonds. So that carbon is there. Does that make sense? And then they would do something like that. And that's how you would tell an aldehyde from a ketone. So what I would say, and I'm going to be honest, there's about one of everything. They say, what is this? Which is why I really like what Parrish did with that little 3x5. That's what I suggested, right? Because they're going to say, what is this? You're going to have to look at it and say, oh, let's see, the O is at the end. That's an aldehyde. Oh, that C double bond O is in the middle. That's now a ketone. Oh, I've got an aldehyde and an alcohol. That's a carboxylic acid. Does that make sense?
Oh, yeah, so in the first one, the H is there just so it has a fourth one.
Exactly. Yes, exactly. And like I said, they wouldn't have to draw that. They would just expect you to know that that carbon's only got 3 bonds. It's got to have an H there as well. Sometimes they'll draw it. Sometimes they just say, hey, you should know that. Does that make sense? Okay.
Yeah, so when they show it to us, is it gonna be like 3D models, or is it gonna be
No,
dense structure?
they're completes.
Okay.
Let me think. I don't remember seeing one that wasn't pretty well drawn.
Okay.
Yeah, it's going to be pretty obvious. There could be a skeleton. I will check. I looked at this morning. For topic-wise, I didn't look for it for specifics, but I'll go back and look at that for I won't see you guys again until Thursday, right? Yeah, I'll look at that again on Thursday. Okay? All righty. Now, from there, how to tell now, anybody know how to tell if something has a really high boiling point or not? Anybody remember? We haven't talked about this in a long time, but we did a long time ago. Okay? Now, ionic compounds have high boiling points. High boiling points. Now, say, well, how am I going to tell if it's an ionic compound or not? Okay. Who remembers? Metal to a non-metal, right? Now, organic compounds all contain what? Carbon, right? In reality, organic compounds, 99.9% of the time, only contain elements that are to the what? Anybody know?
Right in the stage.
To the right of the steps, man. They're non-metals. I put a metal in there, I'm going to immediately assume that this is a what? No matter what. I see a metal, I'm going to assume it's an ionic compound, which means it's going to have a what? High boiling point. Okay? Another way to look at is the number of carbons. Okay? If I've got from 1 to 4, I'm a gas at room temperature. Okay? 5 to 5 to a lot. 5 to a lot is typically a liquid. What happens is they're still liquids. They just get thicker and thicker. Because I was going to say like tar. I mean, tar at ambient temperature at 70 degrees is technically a what? It's still technically a liquid, right? It's just a liquid that has a very high what? Starts with a V. A very high viscosity, right? Okay? That was a good word, though. It did. That's what I'm saying. It did. Now, and the reason I say that is this, is there are states that if you like, let's say, for example, Minnesota, right? Minnesota has a really high water table, right? And when it gets to a certain temperature, you can no longer drive a semi on their roads. Period. Does anybody know why? No, I'm talking a too high of temperature. Like once it reaches like 85 there, you can no longer drive a semi on their roads. Because the asphalt gets warm and its viscosity goes down, and because their water table is so high, they don't have the stability in the earth. And literally, you'll fall right through their asphalt. It's kind of crazy. Yeah, watch the YouTube on this. But, so you need to understand that 5 would still be a really thin. You know, we're talking gasoline, things like that. I want to say gasoline goes from like 8 to like 16. They're all gasoline range, right? And then as I get higher and higher and higher, now I get into, you know, oils and kerosenes and ultimately I'm going to get to tars and asphalts and things like that, right? That's just
The more carbons it has, the higher the boiling.
the more carbons that has, the higher the boiling point. Yep. Higher C's equals higher BP. That's probably the easiest way to look at it. Okay? Does that make sense? Or no? Yeah? Okay. Number of bonds. I wrote down something. I don't remember what it means. All it says is number of bonds. I don't know. I'll have to relook at that. So that's what I got. Shapes and bonds. We reviewed that, right? We did adding hydrogens, right? We did bond polarities, correct? We did alcohols are flammable. And what did you say, Richards?
Like what I just said?
No, earlier when we talked alcohols, you said something.
Like
How
combined.
they dissolve in water.
Yeah, they're also, what's the word for that?
Flammable?
No?
Oh, soluble.
Soluble, right? So alcohols are flammable and soluble. Ionics has a higher boiling point. We just talked about that, correct? We already reviewed condensed structures, didn't we? And we just went over the tables.
Yes, sir.
And then I've got number of bonds. And I do not know what that means.
Okay.
Like the OPRC thing?
No, because we did that last time, didn't we? Right? We did the valent, 8 minus the valence to determine that, right? I don't know. All I know is it's number 21 on the test. So I will revisit that for next time. Yeah. Well, the problem is my 21's not your 21, so it doesn't matter. I just know that that's what I wrote down. Thinking it would, spark my... But it didn't. That sucks.
Yes.
Oh well. Okay. Questions? Remember, before we leave, understand this. We're going to take the test. Test 11 on what is next Wednesday? Next Wednesday's the 31st. Test 11 on 3. Somebody verify that.
That's the 31st.
Test 11 on 3/31. We'll do the lab when we come back. It'll make it way better. Okay? Questions? Yo,
Okay, so why was alcohol soluble in water?
say that again.
Why is alcohol soluble in water?
Okay, so why? Here's a good question. Why is alcohol
The OH.
soluble in water? Anybody know?
It's
Yo.
solar, right?
It is.
And light dissolves light.
It is. There's one other thing it'll do.
Does it steam the OH to turn it into water?
The hydrogen bond, is that what you said?
Hydrogen bond, exactly. Because of the fact that, and it doesn't matter what it is. Like, so, like let's say I look at this one. Let's say I look at this, right? Okay, this right here is called methanol. Okay, methanol, right? Well, I got 2 carbons. That's methane. We'll get into that. Add the OH makes that methanol, right? Now, it is polar, right? Because this is obviously negative, this is obviously positive, right? But it will also hydrogen bond, because remember, in order to hydrogen bond, I had to have an H bonded to an F, O, or N, right? This has an H bond to an O. Water has an H bond to an O, so they will hydrogen bond with each other. So it will not only hydrogen bond, it will also dipole. Do you see what I'm saying? So it does them both. So alcohol and water are very miscible, which is, why they cut alcohol with water.
What was that word you used?
Miscible means they mix. It's called miscible. Miscible. Just means they mix. And that's how, like if I'm making alcohol, I'm making 100%, right? 200 proof, right? Then I'm going to cut that. I'm going to water it down until it's like 100 proof or 80 proof or whatever. And that's what they do. And that's why, is because it mixes very well with water. Does that make sense? Okay. So test 11 on 3/31. This is for B days, right? And then it's going to be 4-1 for A days. And this is not April Fool's, by the way. Well, I don't want kids to get, you know how teenagers are, right? Okay, get busy. Time is yours. Use it wisely.